Okay, so when it comes to solving logarithm equations, these properties are actually not too bad, but the trick with logarithmic equations is that we want to take advantage of our properties of logarithms. And so some of the properties that we want to take advantage of, and hopefully you recall, were things like this. Some of our properties of logarithms said that anytime you had a product in your argument of the logarithm, so the logarithm base b of m times n, we said that was the same thing as the logarithm of m added to the logarithm of n, right? We also had one for division, which went like this: the logarithm base b of m divided by n was equal to the difference of the logarithm of m minus the logarithm of n. And finally, one more property that gave us the logarithm base b of m raised to some power is equal to that power times the logarithm itself. All right, so what could we do? Well, we're going to use that on our left-hand side right here to combine all of these terms as a single logarithm. If you remember, one of our exercises was combining logarithms, or combining sums or differences of logarithms as a single term. So what do we get right here? This is a logarithm, and in this case it's common logarithm when we don't write the base. Remember, that's base 10 that's assumed, of the quantity x times x plus 15. And that is equal to 2. All right. Now our base right here is equal to 10. So if we use our exponentiation trick, right? Our exponentiation trick was the one that said if a is equal to b, then u, the base u raised to the power a, would be equal to base u raised to the power b. So we're going to use that rule right here and exponentiate with a base 10. So we've got 10 raised to the logarithm of the quantity x times x plus 15. And that will be equal to 10 raised to the power 2. Well, our logarithm, base 10, and our base 10 undo one another and leaves us with x times x plus 15. And that's equal to 10 raised to the second power. Well, that's 100. So what do you do with that? Well, this is actually a quadratic equation. Remember those? Yeah, that's right. Let's distribute. We're going to get x squared plus 15x equals 100. And to solve one of these types of equations, either we can complete the square, we can factor if we know how to do it, or something. Let's say if we wanted to factor it, we'd have to set this equal to 0. So we would say, well, let's take x squared plus 15x minus 100. And let's see if there are two factors that would satisfy the equation. Our factors on our left-hand side, let's see. So we're going to have two binomial factors, x and x. And let's see, negative 100. What two numbers could we get to multiply together to give us negative 100, but add up to positive 15? Well, let's see, what are our choices? I know that, let's see, negative 100, that factors, let's see, what two factors could we use? We've got, well, how about negative 20 and positive 5? No, that's not it, right? Because the signs are wrong. How about positive 20 and negative 5? Yeah, right, when we add those together, that gives you negative 100 and adds up to positive 15. So we would have to say x plus 20 and x minus 5 as our two factors are equal to 0. So we would set each factor equal to 0. We're going to get x plus 20 is equal to 0. which gives us x equals negative 20. And then we would take x minus 5, set it equal to 0. By adding 5 to both sides, we get x is equal to 5. All right, so we're done, right? No. Right, we got a problem. Even though we haven't been doing it, we need to actually go back, and because of these logarithms, the nature of logarithms, we have to ensure that whatever answer we get works. So there's another thing to keep in mind. Sorry, there's just a lot of little things that we have to do in these kind of logarithms. Remember that we defined all of our logarithms so that anytime we took the logarithm base b of x, it had to be a domain of something greater than 0, not greater than or equal to 0, just greater than 0, right? So does this work? Well, no, right? In our original equation, we would have to be able to take the logarithm of negative 20, the common logarithm of negative 20, as part of our expression, right? It's undefined. So what we've just found is that x equals negative 20 is an extraneous solution, because it happens to give us a value that would not be defined. But let's take a look at x equals 5. Does that one work? Well, it looks as though I can take the logarithm of 5. That's good, right? And I can take the logarithm of 5 plus 15. That's 20. That's good. And presumably we would get 2 if we added those two things together. So our answer, x equals 5, that's our solution right there. Okay, so we definitely also need to check, especially when it comes to logarithm equations, because in logarithm equations we want to make sure whatever solution we find fits within the domain of that logarithm. Okay, more to come.